So we've already done some confidence intervals back in Unit 6. What makes this unit different is that this is for an average. So this is again for quantitative data. So our goal here is to estimate the population average. So we're going to use the same basic format that we used in the previous unit. It's going to be a sample statistic plus or minus a critical value times a standard error, but we're going to be plugging in different values. So our sample statistic is going to be a sample mean, because that's our best guess of the population mean. The critical value here is going to be T star. So I'll show you how to calculate that in just a second. It's similar to Z star, but it uses a T distribution. And then the standard error is the formula that we learned in class. So that's the sample standard deviation S over the square root of N. So let's look at an example. A manager at an insurance company wants to see how well one of her sales reps was doing, so she randomly selected 30 mature policies that have been sold by the rep and computed the net profit for each of the 30 policies. The sample mean is given here, $1,438.90, and the sample standard deviation is $1,329.60, and we want to make a 95% confidence interval for the mean profit of all policies sold by this rep. So notice that they're telling us what the parameter is, the mean profit of all policies sold by the rep. That's the parameter that we're trying to estimate. Okay, so we still have to check our conditions here. So we learned these for hypothesis tests, they're the same. So it tells us that these policies were randomly selected, so that's good. And then our sample size needs to be at least 30, so this one is just barely there. We've got a sample size of 30, but that'll be good enough. Okay, so we're going to plug into this formula. Our sample mean is $1,438.90 plus or minus our critical value. So for a critical value, we're going to need to use JUMP. So we'll do add-ins, T2 modules, distribution calculator. Okay, so this is quantitative data, so I'm going to change it from a normal distribution to a T distribution. And the degrees of freedom depends on our sample size. So here we had a sample size of 30, so our degrees of freedom would be 30 minus 1, which is 29. And to get a critical value, I have to change the type of calculation. So instead of input values, I'm going to do input probability, and I'm going to look at the central probability. And the probability that I type in is going to be my confidence level. So I want to be 95% confident, so I'm going to put in 0.95 as my central probability. And this number that comes up, 2.0452, that's my critical value. And because this is quantitative data, that value is called T star. So 2.0452. So that's our T star from JUMP. And then I'm going to plug in for the standard error, $1,329.60. That's the sample standard deviation divided by the square root of the sample size. And if I put all that together, then I end up getting the lower bound is $942.43. And then the upper one is $1,935.37. Okay, so you already kind of know how to interpret these intervals based on what we did for proportions. So I have a couple different interpretations here. So pause the video for a second, read these, and then see what you think. Okay, so the correct interpretation is we're 95% confident that the mean profit of all policies sold by this rep is in the interval. So notice this is the parameter that we were trying to estimate, the mean profit of all policies. And we're always trying to estimate the parameter. So that's what you should be looking for. So let's sort of talk about why the other ones don't work. So the first one says 95% of all the policies sold by the sales rep have profits in this interval. So that's talking about individual policies, right? Individual policies, that's never what we're looking for with a confidence interval. The second one says we're 95% confident that a randomly selected policy will have a net profit in this interval. Same problem. It's still talking about individual policies, and confidence intervals are never about individuals. The third one, the mean profit is this amount 95% of the time. So this one doesn't even give us an interval. This is just giving us 1 point, and we definitely don't expect our sample mean to be equal to our population mean 95% of the time. It would be pretty unusual for them to be exactly the same. And the fourth one is we are 95% confident that if another study was done, the mean profit would be in this interval. So this sounds like it's talking about the sample mean and where the sample mean would fall, but confidence intervals aren't about the sample mean. They're always going to be about the population parameter. All right, so let's go ahead and write that one down. We are 95% confident that the mean profit of all policies, all is kind of a clue word here that we're talking about the population, all policies sold by this rep is between these values, $942.43 and $1,935.37. Okay, and the next few questions will be in a Google form to give you a little more time to think it through.